everyone. Today we'll be talking about, or I'll be talking about, and you'll learn hopefully a lot about offline first services. So, who has ever experienced sitting on the train, especially in Germany, as I've observed? You just need to take a train like 30 minutes outside of Munich before you lose your internet connection. It's kind of crazy. And then, let's say you want to get out your favorite app. That app is an air horn app. The air horn, obviously. Bam, you're offline. Okay, this is maybe not the best example because this is clearly a web view wrapped into an app. But let's say you're checking out the snow conditions. You want to check out the snow conditions, but by accident you close the app, and then you're 30 minutes outside of Munich. Let's shortly see. Here I'm just putting the phone into offline to simulate a offline condition. And you're opening up the app, and bam. Make sure your device is connected to the internet in order to continue. Great user experience. I just had the app open 3 seconds ago. It was closed, and now I can't check out my snow conditions. Let's see how Twitter works. So here I'm just browsing my newsfeed. Yeah, my notifications open. I'm just looking at it. Oh, resolution's quite bad. Again, we simulate an offline condition by turning on airplane mode, open up Twitter again. So actually Twitter is quite good. It loads the cached contents, says a message that it can't receive messages right now, but at least we can scroll down quite far and see a lot of the cached content with some images appearing and stuff like that. What happens when we try to write a tweet? Hopefully, that's the next section. Yes. So we write a tweet. We see a nice blue indicator up here, and our tweet will show up in kind of like a grayed out mode. Now what happens if I want to delete the tweet? Cannot delete tweet. Please try again later. They have a bit of issues with offline services, and actually if you take the link and copy it to your clipboard and paste it into a browser, it somehow magically generates a link fully offline. I don't know how. It was an interesting observation, but I thought I'd share. Let's take a look at another app. How does the Guardian work? It's a news app in the UK. We can see that I load a story, scroll down a bit, and after we go offline again and close the app, just to make sure that there's nothing cached in memory, everything should be persisted to the disk. We can see that the Guardian actually has a lot of content cached here. So this is actually not the interesting bit. The more interesting bit is when I scroll down to, okay, so this is another headline news. We see that text is cached, images aren't. And now the surprise is that when you kind of like scroll down to, not yet, this is again a headline news. So we're scrolling down like all the way down to like some subsection, life section of the Guardian, and bam, we still have text. So hopefully quite late text. So how do we build apps that are offline first? So I will be mostly talking about apps, but the concepts here are applicable to web as well. So apps just happen to be what I'm working with these days, but you can actually do a lot of these stuff in the web world and other areas, even desktop. So choose your adventure. I'm a full stack developer. I do React Native and backend, and this talk contains both. So, based on the previous talk, hand raising, I have a feeling most people here are interested in the front end, but a show of hands, who's interested in the front end, and then I'll ask who's interested in the back end stuff. So front end and back end. Oh, everyone's interested about everything. I don't know. Okay, let's start off there. We'll see how I do with time. So a quick prequel. So we spent some of the foundations of Pepperoni came about with the first app I was building. So it was this photo sharing app. Essentially, you went to these concerts in a venue and you uploaded your memories. And you had this feed of images, videos, and everything. So we developed this app in React Native because we didn't have iOS developers. I, at that time, was a Scala developer, but I learned React and React Native in about 3 weeks, so that was a fun thing. And the first time developing a mobile app, we made a serious mistake. The app did not work offline. Essentially, you go into a venue, and anyone who's been to London venues, most of them seem to be underground for some reason. I don't know why, but like all concerts and things, like you're underground. So we quickly noticed when we actually tried it out live, after about like 3 months of building the app, this thing doesn't work. It's like, it doesn't work. The only thing you're supposed to do is upload images in a concert situation. It fails at that. So this is where this whole thing came up, where we started thinking about the fix was actually quite easy. Like, you just buffer the images, cache the images, but this is where we actually started thinking that we kind of need to be building offline first services. So I will tell you my current story of like the app we're working at. So here, it was much better. From day one, the requirement was that it needs to be offline first. So that's much, much easier than doing it after the fact that you built an app and now like you need to make it offline. Designing an architecture that is offline first is much, much easier. So if you ever end up working on a mobile app, one of the first questions you should ask your product owner or the business is, does this app need to function offline? Which features need to function offline? So the front end is very similar to the Pepperoni one, React Native or Redux. We find these tools kind of work. I remember a lot of hands up in the air about Redux. There's a tiny primer on Redux. We might skip it. So who wants to hear, who doesn't know anything about Redux? Okay, yes, our sales MD guy. Okay. So Helmut, we have a stage here. No, okay, we'll quickly go through it. So we have a state. We have our view, which is generated based off that state. We have action creators that just get dispatched. And so what we can observe is we have like a unicycle here, or sort of a cycle that's unidirectional. So how are typical API requests handled? Either through some other form, but usually through an API middleware, where you have kind of like two actions. So first you dispatch a request action, which usually does a tiny thing of setting a isLoading bit, and then the response action, which actually gets the data when the promise completes. So usually what happens is like request actions, you set isLoading true, and then you display a loading spinner. And then when the response is received, you get the data. So what we want to do is actually get rid of the isLoading bit. How do we do that? So these are for actually actions where you're mutating state. So let's say you're, for example, on Twitter liking a tweet, or on Facebook accepting a friend request, right? You don't want to be tapping on accept and then see a loading spinner. You want to be tap accept and move on with your life, right? So we have here two kind of changes to our unidirectional sort of cycle. Number one is we have like an action queue here. So we have all our actions coming in. When you're offline, you kind of queue those actions and don't send them to your kind of API logic until you go online. But in the meantime, you dispatch an optimistic action. And this is where you get a nice user experience. So instead of saying, oh, we're waiting for some information to load, you say, let's tackle the problem optimistically. What would happen if this asynchronous action completes? And in some business cases, you cannot anticipate what's going to happen. Like, you can't anticipate what are the latest headlines, for example. But most actions where you're kind of like sending a tweet, liking a tweet, accepting friends, you can actually just like say that, oh yeah, we accepted this friend, and you can't see their data yet because you're not friends yet, but you can move on with your life and display a UI that is reflective of you accepting their friend request. So what happens when you encounter an error? So you can easily just have a third action, which is an undo action. So we expand from an optimistic action, an undo action, and success action. And these get dispatched in the order of first the optimistic action. When your network request completes, then you either dispatch a success action or an undo action. So the undo action would roll back your changes, the things that you optimistically did. So in the case of liking a tweet, you would first display a little red heart saying that you like this tweet, and then if it fails for some reason, I don't know why it would fail, you would roll back that liking the tweet by making the heart gray again. So it's quite basic stuff, so it's not rocket science. So let's move over to a bit to how we design and communicate with the back. Yes?
Okay. Can we ask questions during the interview?
Sure, yeah, you can. It's maybe better to ask now before we move on.
I think it's really a good workflow, and we actually adapt the same stuff. But however, have you think of a situation that I want one action to succeed just eventually? I don't care how long it takes, I want this to succeed. Exactly like the example you gave, like I like something, probably I'm offline, but in one long line, I want this one to be successful eventually. So which means I want to repeat this request eventually until it succeeds. Have you considered these situations? Like it's not that if I don't have a network and I'm just gonna like it.
Very good point. Actually, that is what I kind of was saying. The undo action is when it's a business failure. So for example, like a tweet, the tweet does not exist anymore, for example, right? Your API, your backend will hopefully say, oh, 404 or whatever, right? That's something you do not want to retry, right? A 400 semantics of that are do not retry. So yes, by default, this action queue kind of repeats itself and constantly tries until it succeeds. Because until you actually try it and actually succeeds and get a response, either a 200 that is success, then you dispatch the action. 400, you would probably dispatch the undo action. 500s, you would try again, hopefully, maybe, I don't know, depending on how you implement your service. But usually 500s, you try again because the backend is unavailable.
This seems to be straightforward for a single action, but what do you do if you queue up 20, 30, 40 of those and 5 fail? So over a journey of some 2 hours, in the end, the user might want to get some sensible feedback on what has actually succeeded, which probably needs some different interaction concepts to visualize those.
Very good question. We're a bit getting ahead of my talk, but that is so. I guess let's take a time to step back. It's very hard to speak about offline first services without the context of domain. Like, unfortunately, or fortunately, I don't know. Unfortunately, there's no golden solution to offline. Like, you can't build one library that handles all offline interactions. So usually you use your domain to restrict your kind of these types of questions of what should happen in these situations. I can't really answer a question like this because it's your domain that defines what's supposed to happen. So I can tell you what we do in these cases. So if you have, I mean, it's going to be part of the backend stuff, but I can go ahead.
We can defer it.
Yes, let's defer it to a time. Maybe after we answer or I'll take a mental note, and the backend side we'll get back to it. So moving over to kind of like getting the backend into this whole situation. So instead of thinking about actions when we communicate with the backend, we will instead talk about commands, because it's kind of an intent or a request. Like, you want something to happen on the backend, for example, to like a tweet. They can be refused because, such as the tweet does not exist. And on the other side, what comes out is an event or a statement of fact that the tweet was liked. And this is actually what we ended up doing, of designing an architecture that a backend included architecture that includes these, is that instead of having RESTful API calls, you have commands and events. So we'll kind of get into the more details of what these mean on the backend side of things, but glossing over a bit, what happens if a command is refused? And these are the cases when the tweet does not exist or stuff like that. So we can store actually extra information with each of these actions that we queue up. So when you're building offline first apps, you need to enrich your actions with 2 other things past the undo and optimistic and success actions. You add an error text and a navigation key. So what the purpose of these is if that action fails, what message should be displayed to users, and if a navigation key, so you can, when the user taps on it, they can navigate back to the same screen that they were. Does this, it partly answers the UX questions. Not really. We can go into maybe more detail later. But looking at the backend stuff. So I already gave away the hint that maybe REST is not the greatest solution to it. So this is how a typical RESTful interface looks like. One thing that we actually encountered when building our, I think, second app is that you can actually get out of sync local cache. So here's an example of where you're getting users 1, 2, 3, and it says it has a follower count of 5. You go offline, you navigate to follower screen, and bam, there's only 4 there. So you can see that even though your main profile information says that they have 5 followers, when you actually navigate to the cached content, it only shows 4. So your local state is kind of out of sync with different resources. And if you imagine your REST API growing and growing, and you have 20 different reasources, if some of those fail, then suddenly you download like a subset of your current state and you will have out of sync. The reason why we kind of ran into this was we were getting, one of our APIs was getting, for example, a list of followers, and when you tapped on it, it said, oh, cannot find this user in the local database because it didn't get it through another API. So REST, we found, isn't the best thing. Also, there's other issues of like general issues of how can you actually build a RESTful interface when it comes to state? Like, how can you keep everything local? And this is where you kind of have to use your domain again to restrict it. Obviously, caching all the YouTube videos on Earth is not a viable solution. So how do you also refresh all your information, such as updates to, for example, a tweet and stuff like that? So you can use a couple of different solutions, such as etag, if modified since, only get the changes / diffs. These all require kind of extra engineering work. While with a command / event-driven model, you get the diffs automatically through these events. And the nice thing about events is that when you have an event, it defines something that happened in your system, and it goes from one consistent state to another consistent state. So for example, let's say if you have a new follower, it just says, here's Tino following you. And then you can update your local state saying like, oh, follower count goes up by 1, and it gets added to the follower list. So in the backend, what we ended up doing is using Scala or Akka, the actor model. I'm not sure how much people know about it, and an event-driven system. We'll get into the actor model a tiny bit later. So the API is actually, this is our API right now. We've been building this service for 10 months, and I can say that very few other backends I've built have a so simple API after 10 months of development. So we just have a post endpoint where we post in an array of commands, and we have an events endpoint where you kind of get it based on a sequence ID. So you don't get all the events, only the latest ones. So let's look at this, how it works, in kind of like a diagram. So we have a post event. This goes to a command router, which routes it to a actor. So an actor, it doesn't, we don't really need to go into the details, but it's essentially a unit of state that is guaranteed to run on one single thread and contain all your state in the backend. This might have been not a good description, but we can maybe go back. This talk is maybe geared more towards the front-end side than the back-end side, but essentially your commands come here, they get serialized. What that means is that they get into a queue, a nice queue, and the actor just processes that queue. So let's say if I want to say like, oh, like this tweet, reply to this tweet, and these are all nicely queued up, and the command actor contains the business logic, and it runs these commands through. And there's 2 outcomes. Number 1, it rejects the command, saying that this is not a valid thing that you can do, or if it succeeds, then it writes it to the event journal. And the client actually gets the events. And this is actually how we have it implemented now, is the client posts the commands, it receives a response of a 200, and then it pulls the events. And then the events, most of the time, get processed in sub 10 milliseconds. So by the time it pulls the events, it gets through to it. So does this look familiar? It's kind of a flux loop in the backend. So we kind of just, if we look back, it's kind of just extending the Redux cycle to the backend as well. And this is why it makes it kind of relatively simple. So if I would rename these commands to their journal to state, commands to actions, and I don't know, events to, I guess the command actor is kind of your reducer in some way or another. It kind of makes sense and is very nice to work with. So this command actor, we use it in a way where it's like one actor per entity. And now we're moving into the land of CQRS, or Command Query Responsibility Separation. We won't really go into that because it's a topic on its own, but essentially we have one actor per entity. So let's say if I have a user in the system, then that user would have an actor for itself, and all commands that pertain to that user, such as changing its profile information, updating its email address, etc., would all flow in, and that actor would be responsible for validating the commands and persisting the events. And just to give a quick example of how this looks on the backend, this is each command has an ID, it has a type, it has a timestamp of when it was sent, and the payload, which contains the command information. And the event looks quite similar. We have an event, and here we have a source command ID. So this is what we use to correlate the incoming command with the event it generates. And the client, or the front-end mobile app, can use the source command ID to know which commands it can dequeue from its action log. I'm not sure if that makes sense. And finally, our schema. This is our schema for a backend being built for over 10 months. Just one table. We have a journal. That's it. It has an ordering, some persistence ID, sequence number, and then just a blob that is the message of the event. That's easy. It's that simple, sir. And what happens if we have millions of events? Well, I didn't really get into this, but the command actor, when the backend starts up, it actually reads the events from the journal and holds the memory, holds the state in memory. So what we can do to have our recovery happen much quicker is first recover from a snapshot, load the state based on that. This is essentially kind of like rehiding state. Play back all of the events that have happened since, and then we're up and running. So you might ask now, which have been already asked, what about conflicts? What about issues with, or rather, I'll get back to your question. So we solved these issues of having 20, 30 actions queued up, all running into the backend. Some of them failed by just simply playing back them too. So there are multiple of these command actors in our backend, and each of them just serializes those commands. And if some of them fail, then they get sent back to the front end. But if the others succeed after it, then it's all okay. The command actor should take care of the validation logic. So as I mentioned, there's kind of no generic solution to conflicts. Like your business domain restricts your possible conflicts. Just looking at these different kind of domains, like a game, which has minimal network interactions. For game, you wouldn't need to think about hard conflict resolution because you usually have high score feature, whatever that needs network. A news site, which is read-only content. Or if you have commenting is kind of like an append only. So there's or you have edits there. So they have minimal kind of conflict issues. A social networking has, again, very different needs, right? You have a lot of interactions, a lot of, again, commenting and editing your existing content and uploading new stuff. So, and I guess this is the domain we're kind of in, where it's this is a business app what we were developing where employees are not handling shipments but doing something else. It's a mission critical app where there's not a lot of conflicts, but it must always work offline. So it doesn't matter if you don't have interact, you should have access to your data. And for example, a document editing service, that is actually one of the tougher ones. I wouldn't say I would be up for building an offline first document editing because you essentially have to implement kind of a git merge with a nice UI that a lot of users understand. So closing thoughts. This was actually the easy part, I think. The technical stuff, sure, it might have seemed a bit complex, but after you get working with it, it's not that complicated. The hard part is the UX and users, actually. We kind of skipped that, but I would love to hear a designer give talks and think this through. There's actually a lot of good articles online that talk about different UX patterns you need to use. But I mean, and at the end of the day, there's humans there. So I think people outside of the tech community do not understand servers and what offline means and what network means and why their phone doesn't always work and why it can't get the latest content. How many people have seen people take screenshots constantly of their boarding passes when they're flying because, oh, it's not going to be there when I'm there. Most boarding pass apps support offline because that's kind of the basic requirement when you're abroad and don't have roaming. But people still like screenshot, screenshot, screenshot. It's changing the user's behavior is and making sure that they understand that this is an offline first app is what's hard. But talking about some of the advantages, the app experience is much, much, much better. So seeing no loading indicators in the app is like marvelous. It's really makes your app feel like magically smooth. You have a rock solid API. Like your API is not going to change anytime soon. You can handle all the API version and logic with custom code because you just have different commands, and those commands get routed elsewhere. So it's like makes it handling much easier. Your backend availability requirements are lower. So your backend could actually go offline for 2 days. Your client would continue working because it would just queue up all the commands or actions. Like it would just be happily. It won't get any new data, but all the interactions, for example, editing comments, doing all these stuff would be nice to queue up. And you get a free audit log. You have immutable ends. You know everything that has ever happened in your system back to the start of time. So disadvantages are that it does require a tiny bit more engineering. Not a tiny bit, maybe a significant amount. This offline first mentality is a bit new. The libraries out there aren't supporting this type of engineering too much, so you kind of need to write a bunch of custom code that handles these situations. Also, it requires a new way of thinking, like actually with designers as well. Like we always have to say, okay, how is this going to work offline? That's the first question I can always ask my designer when they show me a new feature. It's like, okay, how is this going to work offline, right? You kind of need a new way of thinking about every feature. And there are trade-offs that you can make. Like you can't store everything. So at a point you're going to have to call it and say we have to kind of just say that we only store this much and everything beyond that you need to be online to access that. And that's where your domain comes in, and you can actually restrict it based on that. And finally, UX needs to be extremely good. So we're not there yet, I think, with our app to make it extremely clear to users that if you do something in like the middle of Germany where you have no network connection and do something, take your phone, throw it in the river, and then go back to your computer and expect your data to be there, it doesn't work yet. So people still expect that what they do eventually appears, and it's actually, that's the hardest part, I think, is getting users on board with this. So looking at the future, this was actually a lot of custom handwritten stuff, but things are moving forward. So, for example, Redux Offline by Yanni, a colleague, ex-colleague of mine, he recently released this. It's by recently I mean like 2 weeks ago. It's 0.0.1, so don't use it in production yet. But it shows some of these concepts actually in an open source library. So if you found some of this stuff interesting, go check out Redux Offline. GraphQL, I think, will be big. Who's heard of GraphQL? Awesome. So I think GraphQL, it allows you to minimize your network connections by, instead of having a RESTful API, you describe your queries and mutations in large chunks. So you say, I want all this data, give me all that data, instead of fetching separate resources, which kind of solves the problem I was highlighting before. And your mutations look the same way. Instead of saying, I want to first update this user and then update this post, I want to do both actions in one mutation. And GraphQL allows this. Apollo and some of these stuff, they will be good. When we started our app, this wasn't so mature yet. Also, service workers in the browser are going to be big, or actually are kind of already big these days. A lot of new frameworks and libraries and posts are coming out about offline first web browser, which is good for React Native and the React ecosystem generally. So other options, before you ask them, there's a ton of them. You could have done anything else. Like Firebase, people say, like every time I mention offline first, it's like, why didn't you use Firebase? I'm like, because I don't trust that they handle conflicts correctly, or like whatever. I have my reasons. And we did research, and PouchDB is, for example, something that has master-to-master database syncing between the client and the server. There's like Realm, there's Horizon, Rethink, like all these kind of like event-sourced type database. You could have made it work with REST. If someone comes to me, we could talk about it, we can fight about it, like, yeah, you can make it work with REST. WebSockets could have been a protocol, for example, to make this polling, and you can have your events being pushed rather than pulled. Like there's a bunch of other solutions. But thank you very much. I'll leave you with the message of thinking offline first. And here are a few resources I left. And as finally, I've been asked to talk to you about Futurice, your wonderful sponsor today. Futurice is a company founded in 2000. No, I'm joking. If you guys want to do awesome stuff that you saw here today, either with Pepperoni or I don't want to surprise you, but we do other things than React Native. So just so you know, like we do native Android, we do iOS, we do a lot of web stuff. We do stuff with VR, HoloLens, AR. We're a fun bunch of crowd. We do a lot of weird stuff, let's just say that as well. So thank you very much, and if you're interested in the chili corn, grab some stickers. Thanks.